Morning, all of you. We will see the continuation for yesterday's topic, complex reactions. Complex reaction is what? A reaction which takes place in more than one step is called as a complex reaction. In case of complex reaction, the powers of the reactant may or may not be equal with coefficients of the reactants in the balance equation. When it will equal and when it will not be equal, we will discuss now. I am taking one of the example, decomposition of hydrogen peroxide. It is a complex reaction. Should take place more than one step. What is the first step I will write here? See, H2O2 is there, no? It is decomposing like H2O and nascent oxygen. I told yesterday already, a very powerful oxygen, highly reactive oxygen. What is the second step? Out of two H2O2, one is already consumed and one more hydrogen peroxide will be there. It is involved in the reaction with the nascent oxygen atom. You are getting H2O plus one nascent oxygen, one more nascent oxygen. Both are powerful oxygen atoms to combine together is becoming like oxygen gas. Okay. By the combination of these two, we are getting overall reaction. Once you do this one, H2O2 plus H2O2 is nothing but 2H2O2 plus nascent oxygen right side. H2O plus H2O is becoming like 2H2O plus oxygen plus nascent oxygen. Okay, both sides for nascent oxygen is cancelled together. The whole reaction is nothing but 2H2O2 is utilized to 2H2O plus O2. Okay, here important thing. Anyway, the chemical reaction will be taking place in two steps. That's why it's called as a complex reaction. Next point I want to discuss. These two steps is going with same speed. No. Why? Once you see in this whole reaction, some particles are forming in the middle of the reaction and consuming the reaction. They are calling as intermediates. Did you observe this is nothing but intermediate? It is forming in the middle of the reaction and consuming in the reaction. Okay, always intermediate is highly reactive particle. It is nothing but a less stable particle. That's what easily participating in the reaction and consuming in the reaction. My question now, according to that intermediate particle, what will out of these two, which is the slowest step? Anybody? Yes, you see carefully in the first step, intermediate is forming, okay, going with some speed. But in the second step, intermediate is consuming. Intermediate is consuming means highly reactive particle is consuming, means the reaction will be going very fast. Remember, generally, the intermediate formation step is the slowest step. The intermediate consuming step is nothing but the fastest, generally. Okay, now out of the two steps, the whole reaction is depending upon which one. The slowest step already we know that information already told. In two sections I am taking classes, but in one section I completed 4 lessons. In another section I completed 6 lessons. I want to conduct the exam. I have to consider the syllabus of A section only because the process is slow. So that's why the whole reaction speed is controlled by slowest step. That is only we are calling as rate determination step. Rate determination or determining a step. Apply the rate law for that one. According to that one, rate law means what? R is equals to K into concentration of the reactant is nothing but H2O2. What is the coefficient? Will come as it is in its powers. Is it the power in the rate law, the concentration of the reactant power, is it equal with coefficient? No. May or may not be. That's what we call it as a complex reaction. Okay. Now you see one more example I will explain. May equal or may not equal. We will see. Second one, if you take 2N2O5 is decomposing like 4NO2 plus oxygen. Very important concept. You have to see carefully. It is untelling. It is a complex reaction. Immediately we should get an idea it is taking place in more than one step. Then in the rate law, the powers of the N2O5 may equal with 2 or some other number. We can't tell exactly 2. It is exactly equals to 2 in case of elementary reaction. Okay, see first step. What happened? N2O5 is decomposing like nitrogen dioxide and nitrogen trioxide. Is it balanced? Yes. You take second step. One more N2O5 is there that will be combining with which one? NO3. Okay, then what is happening? We are getting 3NO2 plus oxygen. We are getting, check it, 5 plus 3, 8, 3 2 plus 6 to 8. Add them, 2 steps, you are getting resultant equation. So here what is coming? N2O5, N2O5 is nothing but 2N2O5 plus NO3 gives rise to 3NO2 plus NO2, 4NO2 plus oxygen plus NO3 is coming. Did you observe NO3 is something special here because in the middle of the reaction is forming and the reaction is consuming. That's why the NO3 is calling as which one? Intermediate. Intermediate especially is what? Highly reactive particle and a less stable particle. Okay, whole reaction. Right? Now the whole reaction speed is controlled by which step? First one, intermediate forming. Second one, intermediate consumption. Intermediate consumption means highly reactive. Highly reactive means the reaction is going with fast. This is going slowly. The slowest step only we are calling as a rate determination step. That will I'm writing RDS, rate determination step. So then apply the rate law. R is equals to K into concentration of what is coming N2O5. Whatever coefficient will be there coming as it is in its powers. What are the rate law? The powers of the reactant may or may not be equal with the coefficients in the balanced equation. They are equal in elementary reaction. They may not be equal in a complex reaction. Is it equal? Here 2 is there, but here only coming 1. Okay. Now I am telling very important for competitive point of view from the same concept. I am giving one more. You have to observe very carefully. Take 2NO plus O2 gives rise to 2NO2. I am telling it is also complex reaction. Should proceed in more than one step. What is the first step? You see carefully. NO plus O2 gives rise to NO3. It is a reversible reaction. That's why I am telling it's very important for competitive point of view. See the second step. What is it? Out of 2NO, 1 NO is consumed, then 1 more NO is there. That will be reacting with NO3. It is becoming like which one? 2NO2 plus, that's it, no? 2NO2. Is it balanced or no? Yes. The whole reaction will be coming which one? NO plus NO, 2NO, nitric oxide plus oxygen, NO3 coming left side and right side is also coming cancelled together. Finally we are getting 2NO2. That's why it's calling as a complex reaction. My question. So actually this is the intermediate side, it is forming and it is consuming. I told it's not 100% confirmed generally. Okay, but here what happening? This is going fast, this is going slowly. Which step is the rate determination step? Slowest step. That's why we have to apply the rate law for that one. R is equals to K into concentration of NO. Coefficient is how much amount? 1 into concentration of NO3. So power will be 1 because it is falling as rate determination step. Because it is the slowest. Okay, again problem is coming here. Why? So NO3. Can we catch or can we find out the concentration of NO3? No. Why? In the middle of the reaction it is forming and consuming. That's why we won't get the NO3 concentration. That's why it is not the right way to express the rate. But how can you modify this one? That's what we read on here. Concentration of the NO3 cannot be measured or cannot be calculated because it is an intermediate. In the middle it is forming and consuming. But how can you measure it? Take first step. What is the first step? NO plus O2 is reversible with which one? NO3. Okay, it is a reversible reaction. First step is a reversible reaction. Reversible reaction is what will be there? Equilibrium is there. Equilibrium is there means equilibrium constant is there. The formula for equilibrium constant? Concentration of the products by reactant. Just write down. Concentration of the product means concentration of NO3 by concentration of NO into concentration of O2. All coefficients is 1 will come right in powers or no, it's not a big problem. Now which one you want to find out? NO3 you want to find out. NO3 concentration is equals to Kc into concentration of NO into concentration of O2. This is equation number 2. This is equation number 1. Should not stop over there because finding concentration of intermediate is highly difficult. That's why the terms has to be converting into stable chemical concentration. That's why substitute 2 in 1. 2 in 1 equation. Then what is coming? R is equals to some rate constant into NO power 1. No problem here. But instead of NO, what can be written? Kc into concentration of NO into O. Then what can be written? R is equals to K into Kc. NO into NO, it is nothing but NO square into O power 1. Okay, then R is equals to K into Kc. It's nothing but some other constant K dash. No problem. Okay, then it will be becoming like NO square into O2 power 1. Here, we observe very carefully. The rate equation, the powers of the reactants is equal with the coefficients of the reactant, even though it is a complex reaction. That's why we told in case of complex reaction, the powers of the reactant may or may not be equal with the coefficients. It's not compulsory, it should not equal. May equal or may not be equal. That's why it's very important of all of you understood. Why we converted the NO3 concentration to N1 over 2? NO3 is an intermediate, so you should not catch them. Means why? Because it is highly reactive species. That's why you have to convert the concentration term into some stable chemical concentration from using equilibrium concept. Definitely in this type of the reaction, one should be reversible. Otherwise, we can't solve the problem. All of it clear? Yes. The next concept is a very important concept for 2 marks, is nothing but order of the reaction. What is the meaning of order of the reaction? We are discussing carefully. For example, you have a one chemical reaction, X moles of A and Y moles of B gives rise to products. Apply the rate law. According to rate law, rate equation, R is equals to rate constant into concentration of A power X will come, we can't tell. Why? Because whether it is elementary or complex or we can't expect. That's why X will come as its powers are different. That's why we are writing one common number power M into concentration of B power N. So in the rate law, rate equation, whatever powers of the reactant will be there, the sum only we are calling as order. Order of reaction is nothing but M plus N. What is the meaning or what is the definition of the order? That is only in the rate law. In rate law, sum of which one? Powers. Sum of powers of reactants is called which one? Order of the reaction. Are you getting it or not? Very simple. Okay, first of all, whatever you take experimental rate equation, that experimental rate equation, whatever powers of the reactant terms is coming, that sum should be calling as order of the reaction. Okay, first point. Next point, order is the experimental value or theoretical value. It is a theoretical value, means we can take them as a plus, but we won't expect whether they will come in powers or no. That's why compulsory you should do experiment. That's why order is the which value? Experimental value. Why? Because after doing experiment only we can tell whether it is an elementary reaction or complex reaction. Then only we can write the rate law. And order values may be 0 or 1, 2, 3 and so on, and also fractional values. And also fractional values. I will explain for everything one example. Order values may be 0 or 1, 2, 3 and also fractional values. Order will be applicable for both elementary and complex reactions. Elementary and complex reactions. Okay, one more very important point. Order is meaningful. Order is meaningful for whole reaction. For whole reaction. Okay, once again you see what are the characteristics of the order. Order of the reaction is nothing but in the rate equation or rate law or rate expression, powers of the reactant terms is calling as a order. So these powers can be calculated by using only experimental information. This way order is the experimental value. Order of the reaction may be 0, 1, 2, 3, CO and so on, and also fractional values. And order concept we can apply for both elementary reaction as well as complex reaction. Your writing order of reaction is meaningful for whole reaction. Just I will tell all these points. Once again, you see some important information here. Order may be, first of all, I will give you some example for the first order reaction. First order reaction. What is the meaning of first order reaction? In the rate equation, powers of the reactant will be coming 1, means is nothing but R is equals to K into concentration of the reactant power 1. That's calling as first order reaction. What is the example for the first order reaction? Okay, you take one of the example is nothing but 2H2O2 is gives rise to 2H2O plus O2. Will you write R is equals to K into H2O2 power 2? No. Why? It is a complex reaction. Just now we did that. But the rate law or rate equation for this one, R is equals to K into concentration of H2O2 power 1 is coming. Power 1, only one reactant is there. Power 1 which is nothing but first order. You see one more. Just now we discussed 2N2O5 is becoming like 4NO2 plus oxygen. Okay, what is the rate law for this one? R is equals to K into concentration of N2O5 power coming 1 because not equal because it is a complex reaction. Anyway, power is equals to 1, so it is calling as a first order reaction. You see one more thing, ammonium nitrite NH4NO2 is decomposing like N2 plus 2H2O. I am telling that it is an elementary reaction. Elementary reaction is what is the rate law? R is equals to K into, yes, very good, right on, yes, ammonium nitrite. Whatever coefficient will be there, as it is will come in its powers about of it. But why here changing? It is nothing but complex reactions. Okay, in this, what is the order of reaction? First. And very important for competitive, all radioactive decay. All radioactive decay means decomposition of the radioactive chemicals is undergoes also first order reaction. So you won't mention in radioactive decay, you will give us some information. Immediately you have to understand radioactive decay means is undergoes first order reaction. You see some other thing, it is nothing but second order reaction. Second order reaction. What is the meaning of second order reaction? In the rate equation, R is equals to K into concentration of reactant power 2. You suppose two reactants is there, A power 1 and B power 1. Anyway, some should be coming there. It is calling as a second order reaction. I will give you some example. You take for example H2 plus I2 is gives rise to 2H. I am telling actually it is an elementary reaction. Actually elementary or complex we can predict by using an experiment, but I told already elementary. Elementary is blindly we can write R is equals to K into concentration of H2 power 1. Whatever coefficients will be there will be coming as it is in its powers under elementary reaction. What is the order? Order is equals to sum of the powers is nothing but 1 plus 1, it is nothing but second order reaction. Okay, I will give you one more thing, is nothing but CH3 COO CH3 plus NaOH. What happening usually? Okay, CH3 COO means it is nothing but ester or COO or ester families. Okay, here what happened actually, if you want to show clearly, C double bond O and O CH3 will be there. Which one will be breakdown? Actually will come like this. Which one will be breakdown? Between oxygen and carbon, the electron will be shifting towards oxygen like this. Then we are getting here minus, here plus. NaOH is breakdown, Na plus plus OH minus. What happening? This minus will absorb Na plus. So we are getting CH3 COO Na plus CH3 plus and OH minus. It is nothing but methyl alcohol we are getting. Okay, breaking negatively with all things. I am telling it is also elementary reaction. So what we can write? R is equals to, very simple, right on, concentration of CH3CO over CH3 nothing but ester power 1 because it is elementary as this coefficient will goes in its powers. And what other chemical, NaOH, which coefficient is nothing but 1, it is nothing but 1 plus 1 is equals to 2, so it's calling as a order is 2, that's why I calling as second order reaction. All of you clear? Yes. Okay. See, third order reaction is nothing but reactants are converting into products. Here, how many moles will we take? It's not a matter. So now write down the rate equation. R is equals to K into concentration of reactant power coming how much? 3. So that 3 may be written as like concentration of A power 1 and B power 1 and also C power 1 together will be 3. If you use 3 different chemicals. No, if you are using only 2, A square and B, then also we are getting 3. No, otherwise you are taking A1 and B2. Whatever it is, the sum should be coming 3. That's what is calling as a third order reaction. Okay, I will give you one example for this one. It is nothing but 2NO plus O2 gives rise to 2NO3. I told in one step it is actually complex reaction. In one step equilibrium is existing and finally we derive a rate equation. R is equals to K into concentration of NO square into concentration of O2 power 1. Even though it is a complex reaction, the coefficient will be coming as is in its powers. That's why we did it is a special case and special important information. That's why we did which one? 2 plus 1, it is nothing but 3. Order is equals to 3. Are you getting or no? Yes. Now I will give you one more example. 2FeCl3 plus stannous chloride SnCl2. It is going in the reaction, we are getting 2FeCl2 plus SnCl4. Balance now check it. Yes. 2 these are 6 plus 2, 8, 2 these are 4 plus 4, 8 fluorine atoms. Okay, now I am telling it is an elementary reaction. Elementary reaction is we can write directly rate law R is equals to K into concentration of FeCl3 coefficient will goes as it is its powers and SnCl2 what the coefficient 1 as it is goes its powers. It is nothing but 2 plus 1 is equals to 3 is nothing but order is equals to 3 is calling as third order reaction. All of you clear? Yes. Now we will see some other order of the reactions. Okay, order may be 1, 2, 3, 4 like that over. Now I am giving example for the fractional order. Fractional order. Fractional order means what? You have a chemical reaction, reactants are converting into products. Whatever coefficient will be there, it's not a matter. But after writing rate law, R is equals to K into concentration of reactant power 1 by n. Some fractional values is coming 1 by 2, 1 by 3, 1 by 4 like that. That's what is calling as fractional order of the reaction. Just I will give you one example. You take CO plus Cl2. We are getting COCl2. Carbon monoxide plus chlorine, we are getting which gas? Positive gas. Carbon and chloride we are getting. Okay, it is a complex reaction. Complex reaction is actually is the experimental value. Just I am writing R is equals to K into concentration of CO power 2 and concentration of Cl2 power 1 by 2. Complex reaction is what taking place in more than one step. In one of these steps it is going very slowly. That from that we derive the rate law. This is nothing but 2 into 1 by 2. So what is the order? 2 plus 1 by 2. 2 plus 1 by 2 which is nothing but 5 by 2. It is the order. Is it rational value or no? Yes, it's nothing but 2.5. You can see one more thing. Example for this one. Acetaldehyde you can take. Acetaldehyde decomposition is becoming like CH4 plus CO2. It is also complex reaction. Complex reaction is the coefficient may comes or may not be coming in its powers. It's not coming here. R is equals to K into concentration of CH3, CH4 whole power 3 by 2. Because they are not coming, because it's a complex reaction. Complex reaction is taking place in more than one step. In one of the steps, its coefficient is 3 by 2, that's why it's coming powers. So then order is equals to powers of the reactant is nothing but how much? Pivot. Fractional orders. Now I will give you one example as a very important for 2 marks. Zero order reaction. Zero order reaction. I told order may be also zero. What is the meaning of zero order reaction? Imagine you take one of the chemical reaction, in that reactants are converting into products. Okay, whatever coefficient is there, it's not a matter to us. Then write down rate law or rate equation. According to rate law, rate equation, R is equals to K into concentration of the reactant power 0. That's calling as zero order reaction. What does it mean? So according to rate law, R is equals to K into R power 0, means anyway sum of the powers of the reactant term should become 0. That's what is calling as zero order reaction. But what is the definition? Indirectly nothing but R is equals to K into anything power 0. How much amount? 1. Means the rate of reaction, is it depending upon this one? No, that's fine. It's a chemical reaction in which, there is only a chemical reaction in which rate of reaction is dependent or independent? Independent on concentration of the reactants. It's calling as which order? Zero order. This is a very simple and very important one. It's a chemical reaction in which the rate of reaction is independent on concentration of the reactant. Whatever concentration you can take, the speed is not changing. That's calling as zero order reaction. Okay, over. Okay, you see one more thing. It is nothing but, for example, I will common example I will tell. For example, you have milk. You want to convert it into